Cool. So I guess we have started.
Yes.
Yeah. Okay. Now trees. Okay. So first, let me clear you with a few of the क्या बोलते हैं, like maybe some analogies or some terms on trees. Okay. So what you have seen in binary trees is like each node will have either 0, 1 or 2 nodes, right? This is what a binary tree is, correct? True. This is what a binary tree is. Ki there is a root, you will go left, right. I mean, there can only be 0, 1 or 2 children. Agree?
Yes.
Yeah.
Yes.
But when we talk about normal trees, a tree can have n number of children. Okay. Something like this. Okay. Now, this is known as same root of the tree. Root of the tree. Okay. These are known as, what do you think?
Successors.
No, what is this?
Like a child. Or
Leaves, no? These are leaf
Nodes.
nodes.
leaves.
Leaves.
Yes, yes,
Leaf.
yes.
These
Leaf.
are leaf. Okay. These are internal nodes.
Internal. Yeah.
Okay. These are internal nodes. Right. So what we will be having is we will be having two types of categories generally in problem. Okay. So they might give you something like this. This is also a tree. This is also a tree. Okay. So do you think this is looking kind of a graph? Graphs पता है मतलब at least, but I mean some visual representation. Okay, fine. No
Yes,
Yes.
worries.
yes.
Yeah. So what I'm trying to say is, so I guess we should probably discuss about maybe a definition. Okay. What is a tree definition? Okay. So can anyone at least try what's a tree? Okay. ठीक है. So there are
Tree could have a root node with 1 to n children.
okay. Okay. Yeah. Fine. Nice. So I mean, like that's not a proper definition, man, but we should come with some proper definitions. Okay. So first definition might be a tree is something which have n nodes and n minus 1 edges. Okay, it is true every time. A tree will have n nodes and it will have n minus 1 edges. Okay, understood? This is the first definition. The second definition would be, and if there are n minus 1 edges, and there should not be, it should not have, it should not have any cycle. Okay, it should not have any cycle. Any two nodes, if you pick any two nodes, okay, if you pick any two nodes u comma v in a tree, if you take any two nodes, let's say u and v, okay, there will always be there will always be an unique path. Okay, there will always be an unique path from u to v. Okay, what do you mean by this? See, in graph there can be cycles also, right? In graph there can be cycles. So let's say like this, if you have to reach from here to here, how many ways are there? Tell man, if you have to reach from here to here, how many ways are there?
3.
Three, right?
Three.
3.
One is this path, one is this path, one is this path. Can I say this? Three paths.
Yeah.
So in graph there can be multiple paths, but in tree there will only be one unique path. That's all. Okay, because there is no cycle, so you will
Okay.
there will always be a unique path between any two nodes in the tree. Okay, so a tree is generally categorized as probably with these two definitions, that it should have n nodes, n minus 1 edges, and there should not be any cycle for sure, and any two nodes with there will be always be a unique path from u to b. Okay, have you guys heard about the term forest?
Hmm.
Deva?
Yeah, I mean, I just heard it, but I don't know the definition. Yeah, I just heard it.
Okay, so
No idea.
okay, yeah, forest is something as, it's a graph. So each of the, there is some terminology which is known as component. Okay, if each of the component, if these are three components, one, two, three. Okay, so this is actually a graph, but a graph is known as a forest if each of the subcomponents is a tree. These are all trees, right? Can you see? These are all trees, n nodes, n minus 1 edges, and there are no cycles. So a graph is known as a forest if each component is a tree. That's all. Clear?
Okay, graph is not
Okay.
forest.
Okay, Manan, clear?
Yeah.
Sure, right?
I
Yes.
mean, a graph can be a tree, right? It
A
means
graph can be a tree. Yes, this is actually a graph, but this is a, specifically it's a tree because of the this property.
no cycles.
Yes, it does not have any cycles.
Okay.
Okay, now okay, so these are just some terminologies of trees. Okay, now, so I just told you, right, we will be dealing mainly with two kind of trees. Okay, first is unrooted, second is rooted. Okay, let's come to unrooted. Unrooted is, you're just given some random tree. Okay, this is a tree. Don't think tree is only of this structure. This is also a tree because it is following all the properties we just discussed, right? This is a tree. Now, in the questions where they do not mention you any root, okay, most of the time you can convert an unrooted tree to a rooted tree. Okay, that means you just have to consider arbitrarily any particular node. You might take this, you might take this, you might take this, anything. Okay, let me take, let's say this node. Okay, so let me keep some numbers also, would be probably helpful in order to understand. Okay, 4 5 6 7 8 9. Okay, so this is an unrooted tree. Now if I can take any particularly node as root, let's say I'm taking 3, the structure will look like, are you guys understanding?
Yeah.
If I
Yeah.
take a particular node and if I root it, what do you mean by rooting? Rooting means take that as a root node. If I root that particular node, the tree will look like this now. Okay, this is an
Yes.
arbitrarily some random tree given to you, which is an unrooted tree. What you chose to in order to solve is, you chose any some random node, okay, rooted that, and this will be the children's, right? Like this, like this, like this. Okay. Is
Yeah.
it clear what is an unrooted tree?
Yes.
Yes.
Okay,
Yes.
and
Yeah.
basically this is known as rooted tree, that you have some particular root fixed, you have something. In most of the questions they will give you unrooted tree, where you can take any particular node and solve it. Okay, in case if they are giving you root, that means there must be some intuition behind that. Otherwise most of the questions you see it is an unrooted tree only. Okay, so
Oh.
in most of the cases what we do is we choose node number 0 as root and we solve the problems. Actually you can solve with anything, but node 0 is something which is the parent which we consider in solving problems. That's all. Okay, is
Okay.
the two
Yeah.
terms clear for three of you? Are these two terms clear?
Yes.
Yeah.
Okay,
Yes. Yes, bro.
chalo, ठीक है. Now next we will learn a technique in order to travel a tree. Okay, we have a tree, but tree के अंदर तो जाना है ना. We should go and we should explore, right? If we don't explore, what we can do? We cannot do anything, right? So we have to kind of visit or explore all these nodes. Okay, so there is a very famous uh, algorithm which is involved to travel. Okay, and there are actually two, speaking, and you would have definitely heard this: DFS and BFS. How many of you know this?
Yes, yes.
Yeah.
Depth first search, breadth first search,
That's first
Breadth
search.
first search. Yeah.
right? मालूम है मतलब what is the difference between them?
Yes, yes, bro.
Yeah, it'll go breadthwise and it'll go iterate to the last node of that particular thing and then go up.
Okay.
BFS means level by level.
Yeah.
When it comes to DFS, every node
Depth.
order,
Go
like
to depth.
a horizontal way.
Okay, fine. ठीक है. So Manan, do you know these two terms?
I know, but I don't remember now actually.
Okay, cool.
Like,
No worries. So see, in trees we will own most of the times, probably 90 plus or 95% of the times we will use only DFS. Okay, not BFS. Now why that is the case? Okay, tell me why these two techniques have been discovered. If we would have only DFS, what's the problem? See, DFS is going to at most depth and coming back. Correct?
Yes.
Yeah.
Yeah.
BFS is traveling all the nodes at the same level, right? So in case if you want to find, let's say, some kind of shortest path, you have to use BFS, right? In general, because BFS will give you all the nearest neighbors. Okay.
Mm.
But when it comes to DFS, you cannot use shortest path for DFS. Now this all terminologies I am talking with respect to graph. Okay, so probably I should not take this question now, but I just wanted to only tell that DFS is used as similar to BFS in trees, because shortest path, there is only one shortest path, right, in trees, because we know that there is only one unique path between two nodes. So the shortest path is that either you do BFS or DFS, doesn't matter. So most of the problems can be solved using DFS. Okay, now let's see what is DFS probably and how it works in trees. Okay, so since I mentioned that we will only be dealing with rooted trees, let me draw a small root. I mean a small tree probably. Okay, Manan, please listen to this carefully because we require this. Okay,
yeah.
this is node number 0. This is node number 1. Node number 2. Node number 3. Node number 4. Node 5. Node 6. Node 7. Okay. Now, what is root? 0, right? Correct? So
Yes.
what we do in DFS is we start with root and we start visiting. Okay. So from 0 we go to 1 first. Now 1. So do you see any children for 1? Is there any children for
No.
1?
No.
No,
No.
No.
leaf node.
So the recursion will come back. Okay. Now we will start visiting the other childrens. Okay. So let's say we go to 3. 3. Okay. So we visited C. So the order we visited is 0, 1, 3. Okay. From 3 can we go to somewhere else? From 3 can we
Yes.
go to somewhere
Uh,
else?
Yes, we can go to
6.
6.
We can go to 6, right? So we will go to 6.
Yes.
Okay.
Yeah.
Do 6 have any other childrens to go ahead?
No.
Okay. Let's come back. Let's come back. Now we still have this path to be visited, right? I mean, we still did not visit. So recursion will go here, which is 2. From 2, where can we go? We can go either here or here. Okay. Let's say we are going this path, which is 5. From 5, we can go to 7. From 7, can we go further ahead anywhere? 7 से जा सकते हैं?
Bro, first we should go to 4, right? Like
No,
left side,
no,
nothing, no rules
there is
like that.
no rule like that. Recursion can independently take any action. You don't have any control over recursion. Okay, it can go
Okay,
anywhere.
okay.
It might go to 4, it might go to 5. We don't know that. Okay, it
Then
might
if
go.
you want to print the BFS of a tree, then it will be different answers, right? We can have.
Yeah, obviously we will have 0, 1, 2, 3, 4, 5, 6 like that. But
Yes,
in
yes.
general, since we are talking about DFS, I'm just explaining how DFS
Yeah,
works.
okay, 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 got it.
Okay, now 7. So can we go anywhere from 7? Manan,
No.
can we go anywhere?
No.
So where we will go? Our recursion will come back here, right?
5.
From 5, can we go anywhere else?
No.
From
2.
I mean, this is just back. I mean, just going back. That's all. I mean, recursion will go back, right, after exploring all the things. Okay. So from 2, can we go anywhere?
4.
Yes. ठीक है? उसके बाद it will come back, and you are done. ठीक है?
Done.
So if time permits, in one of the advanced classes, maybe, I am not sure, whatever you are seeing now, this is known as DFS tree. So did you guys hear about Tarjan's algorithm? Hey, Deva, you should have known this.
You,
Thousands
I,
of them. No.
I have heard it, bro, but
You heard it?
couldn't.
Okay, nice. So Tarjan's algorithm is a algorithm in graph. Okay, for that you need to know DFS3. Okay, but anyway, I am not taking this now. But Manan and others, is this clear how the DFS works?
Yes.
Yeah.
Yeah.
Okay. So today for today's class we will take up a simple problem. Okay.
Okay.
The problem is you will be given a tree. Okay. Obviously a rooted one. Something like some random numbers. Okay. So what you have to tell is for each of the node. Okay. Hear this properly. Listen to this. For each of the node, you have to tell me some information. Whether it is leaf or not. Okay. What is the depth? Now depth is from root से लेके from root to that node, what is the depth? Okay. So let's say about 4. 4 is having depth of 2. Okay. Because this is 1, this is 1. Clear? Depth matlab, what is the depth from root to this node? Okay. So you have to
Yeah.
calculate whether the node is leaf, what is the depth. Okay, I should have, okay, also, what is the parent of that node? So parent, you know, right? For 4, what is the parent?
3.
For 3, what is the parent?
1. 0.
1.
0,
I mean 0.
right? So parent is just the top. I mean, uska parent, बस उतना ही, ठीक है? Now, for 3, how many childrens?
2.
Right.
2.
2, right? 2 childrens. So for each node, you have to calculate whether that node is leaf or not, what is the depth, what is the parent for that node, how many number of children it is having. Okay. And there is one more thing. So there is a concept which is known as subtree. Okay. So what is a subtree? Subtree is take any node, okay, take any node, all of its descendants, including that node, is known as subtree. Okay, maybe I should explain with some big example. Okay, the subtree of this node is nothing but this. Okay, clear? This is one subtree. This is
Yes,
one
yes.
subtree. This is a entire. This is an entire subtree. I mean sub. So if we root that, let's say any node, if it is rooted, whatever the childrens you have, the entire thing is known as subtree. Clear? Subtree clear hai?
Yeah, okay.
Devamanan?
Like, bro, do you have any formulas for this number of subtrees of a tree like that? Like subarrays?
Bhaiya, we will. Next question
Okay.
is only. Next.
Okay, okay.
Okay. So at least Manan, Deva, are you guys clear? Subtree kya hai?
Yeah.
Yes.
Okay, so what you have to find is size of the subtree. Okay, Sam, is that the question, right? How many subtrees? I mean, how many nodes we have? Size.
Yes.
Okay, so
Uh,
today
okay.
we will talk about these 5 terms, and maybe next class we'll take some advanced things. Okay, so we should code it up all these 5 parameters so that we have the information for each of the node. Clear? So, पहले 5 are these 5 terms clear to all of you?
Yeah.
Yes.
Yes. Size of the subtree means number of subtrees only, right? Like you mean?
Number of, yeah. So for this node, what is the subtree? I mean, what is the size? 1, 2, 3, 4, 5, 6. So 6.
Okay.
This is 1. This is 1.
Okay.
This is nothing but 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. This is 1. This is 6. This is 1. This is 1. This is how much?
3. 1.
1.
ठीक है ना?
Yeah. Okay.
Okay. चलो. So we'll create a folder now. Okay. I'm just trees. Okay. File. What shall we keep? Tree. Intro. Right now, in the question, in any question in LeetCode or any at any platform, you will be given like this. You will be given n, okay, and you will have u comma v, the edge between them, n minus 1 times, right? Why n minus 1? Because there can be only n minus 1 edges, right? So they will give you 5, okay? They will give you 0 comma 1, 0 comma 2, 1 comma 3, okay, 3 comma 4. This is the input they will give you. Okay, there are 5 nodes and this is the edge between two nodes. Okay, so how will you construct? Can I say this?
Yes.
Clear?
Like
Devang?
we can take any random route.
Yeah, we can take one also. I have just written something
Okay.
by considering 0 as well.
Okay.
Yeah.
Got it right?
Yeah, bro.
Okay. The next question is,
Yeah.
they were only giving us this, right?
Yeah.
This 5 comma this space n minus 1. How will we store this in, I mean, which data structure, or what do you think? How can we make so that it becomes easier for me or for us to store this information? Think of that for a minute. Till then, I will do a little bit of quick setup. Okay. So, any ideas? This is data structure problem. That how will, since you guys are exploring it for the first time, you have to come up with maybe some approach. Ki how can I store some information? Ki 0 is correlated with 1, 1 is 0 is related with 2, like that. 2 is related.
Map.
Sorry.
Hash map.
Okay.
Key.
Map of what? Yeah, that's a good thing. Map of key comma value, right? What is key?
Index. I mean,
Node. I mean node. Matlab ye node. Can I write this
yes.
node?
Yeah.
And value should be.
Array list.
That is nice. Why array list? Because there can be multiple, right? One can be with 0, one can be with 3, like that. Okay, this is one good option. Okay, and
Yeah.
in fact you can use this. There is no harm in that. Okay, but I'll teach you some other way, which is everyone in general
When
uses that.
when it comes to binary trees, only array list, right? No need of map this one.
No, in binary tree you have a structure which is only left and right, right? That's all.
Yes, yes.
Yeah, so you don't need list also. I mean, you just have some structure defined already, left comma right with right. That's all.
Okay,
You
okay.
can use this also. You can store left and right. There is no harm. You can store anything. Okay. But in
Okay, okay.
binary tree, I mean, it is very simple. Rather than using this, you can just use simple normal structure. Okay. So what we will be using today is, uh, तो एक काम करते हैं. We will create a different class. Okay. Class maybe DFS something like this. Okay. This is just a class where we will use all the information to solve this problem. Okay. So this can be used using, I mean, in general we use something as list of list. List of list. Confused? What is list of list? What's a 2D array? N into M, right?
Yeah.
It will have some definite size, N and M. Here you
Yeah.
can kind of try to expand it. I mean, what's the difference between a normal array and a list? Normal array you will have a fixed size, some defined. In array list you can put to a good amount of limit, right?
Yeah, dynamic size.
Yeah.
Dynamic space. So here also it will be list of list. That means you will store something like this.
Hmm.
This is the visual I'm giving you. Okay.
Hmm.
Okay. This is what you will store. Ki bhai, this list, the first list is nothing but this, and there is one more list, right? Inside this is this.
Yeah.
Okay. List of integer. Clear, Manan, Sam?
Yeah,
Yes.
it's like the adjacency list, right?
Yes, adjacent.
Yes.
Adjacency graph.
Yes, sir.
मनन क्लियर.
Yes.
ओके ठीक है, तो लिस्ट ऑफ लिस्ट बनाएंगे हम लोग. ठीक है.
Hmm.
Okay, list of this is known as adjacency list in general. Okay. We need number of arrays also, correct? We need edges also. Okay, we need edges also. Now we'll create a constructor where we will pass this two information. So are you guys understanding what is n and edges? N is number of node, edges are that u comma v. Okay. Okay. So
Yeah.
first thing what we will do is we need in Java, what is the basic concept? The basic concept is you have, in order to instantiate something, you need to create that object, right? So
Yeah.
list of list can be instantiated using like this adjacent, I mean new array list. Okay.
Yeah.
Okay. Now how many we have total? 5, right?
Right. Yeah.
So what we will do is, for we will add. Okay.
Yeah.
This is dynamic, right? This can be dynamic, as many as possible. So if you see, I have added for each of the position, add a dynamic array list. Okay. As you
Yes.
practice, you will get hands on it. I mean, nothing to worry about on that. Just understand for now. Okay.
Yeah.
Okay, sure. Now what we need to do? We need to travel on edges, right?
Yeah.
Okay. So how many nodes will be there? 2 nodes, right? 2 nodes
Yeah.
रहेगा ना? There are,
Yeah. V.
yeah, like which 2 nodes are connected? Okay.
Yeah.
Okay, so let me just do this quickly. I'm just initializing this. Now the reason I'm initializing because I will pass it from here, from the main method. Okay, so there are two nodes which will have an edge between them, right? So what we need to do is, for you, let's talk about this. Let's talk about 1 comma 3. Okay, 1 is having 3, 3 is also having 1. So what we will do, the meaning of this is, go to index u, उसके उसमें v add कर दो and add v. Okay, similarly what will be the next one, Sam? Sam,
Yeah.
for you have added v, for v also we need to add u, right?
E.
Essence of get v dot add u.
What, Sam, wasn't it clear?
No, like can you draw that draw image?
It's
This
like
is,
you're making a bidirected graph, right? Instead of uni.
yeah, this is what the information, right?
Yes.
This is edges array. Manan,
Yeah.
listen to this also, okay, carefully. 0 comma 1, 0 comma 2, 1
Hmm.
comma 3. The first thing what we have defined is, right,
Yeah.
using this for loop. Okay,
Yeah.
now this is u, this is v. Okay, what is
Yes.
u? U is 0. For 0, go to index 0, add 1. Okay,
Yeah.
for 1,
Yeah. Okay.
go to index 1, add 0. Next, for 0,
For going back, why 1 and 0? Like
okay, so why, so always this is an undirected tree. Okay, whatever the trees we are drawing, these are undirected. That means you can come from here, you can go from here also.
okay. For
Not
that,
a
okay.
direct.
Okay, sure.
Okay, so now, yeah, so 0 is also having 2, 2 is also having 0. Clear?
Got it, bro. Clear.
Okay, Manan, clear? Deva, I guess you are clear,
Yeah.
right?
Yeah.
Yeah.
Okay, ठीक है, तो this is how we did it. Okay, now what information we require? Boolean is leaf, correct? Int
Hmm.
depth. So why I am taking array? Because we want to calculate for all the nodes. Okay, int subtree size. Next, int parent, int number of
So,
child. Okay,
and
so fast, little quick, we will just initialize everything, and I hope you guys know this, right? Whatever I'm writing. Depth done, subtree size is done. What do we have more? Parent and okay, clear? I just instantiated everything. Clear now?
Yeah.
Now bolo bhai.
yeah.
What, Sam? Not clear? Did you lose the connection, Deva? Confirm it.
No. We are able to hear.
Okay. She's not understanding.
No idea on that.
Okay, I'm just going ahead. Okay, if in case if you guys have, you and Manan have any questions, please ask me. Okay. Now,
Yeah. You know.
while doing DFS, okay, remember, in graphs, since there can be cycles, we will use something as visited array, so that we don't go to same node again and again. Okay,
Yeah.
in graphs we use something as visited array to keep track of which nodes have been visited already, so that we don't fall into a cycle. Okay, But
Yeah.
in trees, there won't be any cycles.
Cycle.
That means what we can do is for each node, okay, when we are doing DFS, we need only one property, that is the parent. Okay, we just have to keep track of the parent. That's all. Clear?
Yeah.
Manan,
हाँ
क्या थक गए क्या?
नहीं नहीं नहीं
Okay. In DFS, I'm just going to write DFS. Okay, so I'm explaining each and every term. The first thing which we took is node, that is which node we are at. For this node, what is my parent node? Okay, and we also can keep track of the depth. That is from root, what is the current depth? Okay, so remember this, since we don't have anything as uh, a kind of like DP stuff or whatever. Okay, so we can try to keep as many parameters as possible. It won't harm you because in tree the DFS time is big O of n itself. Okay, so when you do a DFS, right, it would take you only order n time. So you can try to keep as many parameters as required in order to solve your problem. Okay, now this fact, whatever I'm just telling you guys, it would definitely help you in solving other problems because you need to keep track of what are the information I need. Okay, now as soon as I enter, what should be my first thing? The first thing is, can I say my depth of this node is nothing but current depth? Can I say this, that this node has a depth of current depth? Okay, clear?
yes
The parent, since we are also maintaining, can I say this, key, the parent is nothing but parent node. Okay,
parent first one
okay. Next thing, we will do DFS. So when we are at this node, what we will do, we will try to visit all the neighbors.
the nodes
Yes, all the neighbors. Okay, so what we can do, probably we can write a simple for loop for integer neighbors. Can I write like this, that for this node we maintain an adjacency list, right? Did you remember we maintain an adjacency list? So what we will do
Yeah.
is,
Yeah.
for this node we will try to go to all its
Neighbors.
adjacency nodes. Yeah,
Mm.
neighbors. Okay, now
Mm.
there is one condition. Consider case 2. 2 is having how many neighbors? Neighbors, not children.
one
1, right? This is 0.
Yeah.
So
Yeah.
we would have already visited 0 and come down to 2, right? Sure, that was pretty much intuitive because पहले parent visit करेंगे, then only we will visit child, right?
Yeah.
yeah
So what we will check is, if neighbor equals to my parent node, don't explore, continue. That means don't explore because it has already been visited. So why do you want to go again and again, right? We don't want to
Yeah.
do that. Otherwise, I know that I can go to any of my children, correct? So my neighbor will become where I am going to visit. Can you tell me what will be my parent?
The current.
Yeah, if I am at 1, I am going to 3. So for 3, who is the parent? 1, right?
Yeah.
So 1 is nothing but node. I can probably write this just to have more. Manan, are you understanding?
can you tell what neighbor is equals to parent node
ये वाला?
हाँ हाँ
तो देखो, when you have a tree something like this, okay, for 1, so for 1, what the neighbors are 0 and 3, right?
yes
What is 0? Parent.
parent
तो 1 को आने के पहले you would have already visited 0, right?
Yes.
So why do you want to go there? You don't want to
Correct.
go there. So that's the
Hmm.
reason I just wrote continue, so that we will
Oh,
not go there. That's all.
okay. Yeah.
Okay.
Hmm.
Otherwise, if it is a child 3, we will go to 3, but who will be the parent of 3?
Current node. ऊपर का.
Yes.
Yeah.
So,
Hmm.
and obviously depth तो बढ़ेगा ही एक plus
Plus one. Hmm.
देवा clear?
Yeah.
Yeah,
चलो ठीक है, clear right? Now,
yeah, bro.
okay. So what information we have already available? Depth हो गया, parent हो गया.
Yeah,
What do we need? We need ease leaf, subtree side, and number of children. Okay. So
yeah,
can I say if I am going here, this is my children? Can I say this? If it is not my parent, then it is my children only, right?
yeah,
Right. So number of child of current node plus plus. Can I write this? Agar it's a parent, then don't travel. Otherwise, it's my children only, no? So in that case, I will just increment it.
yeah.
Yeah. Correct.
Correct?
Hmm.
Sense?
Yeah.
Does it make sense? Yes.
Yes.
Okay. ठीक है. So number of children answer is also done. Leaf. We want to calculate leaf. Correct. Leaf is a boolean. So can I say if my number of child of current node is equals to 0, is leaf of current node. Can I say this? Think and tell me. अगर उसके पास कोई भी children नहीं है, in this case, this does not have any children. Can I say this is a leaf node? Can I say this is a leaf node?
Yes. Hmm.
Yeah,
So
Doing.
if it
Sorry,
is,
maybe adding. Hmm.
yeah, okay.
Hmm.
Otherwise, it's not a leaf node, okay. Do you think I should write a else case in this case, or should I remove? Can I remove this?
no, it's not okay. I mean, it's okay.
Uh,
By default, you have false, right?
yes, by default we will have false, right, in Java.
False.
Yeah. So
Yeah,
it's
so
not
it's okay.
required, but I'm just writing it. We can remove it also. Whatever. Up to
Yeah,
you. Now, so how many things we have calculated? Depth हो गया, parent हो गया, child हो गया, and leaf also we are done, right? Now we are only left out with subtree size. Now for subtree size, there is a very good property, and you should know this. And once you know, you can calculate that very easily. इसका subtree size कितना है? ये नोट का.
so 0.
One.
Okay, yeah. It
इसका
considers one. Yeah,
One.
इसका
Two.
right? So can I say इसका equivalent to ये children plus
left,
children
First.
plus
right.
1 क्यों? क्योंकि for this node
Yeah,
plus all the children, correct? Child 1,
yeah.
child
Got
2,
it.
up to so on.
Yeah,
That's all right. Clear, no? Okay.
Yes. Huh.
yeah, yeah.
Hmm.
So what we will do is, as soon as we enter into DFS, okay, subtree size of current node equals to 1. Why 1? Because this is the current node, correct? So एक तो होगा ही होगा for this one, for sure. Now we need for children's. After my DFS, can I say my child will have the answer? DFS होने के बाद मेरा children के पास तो answer होगा ना? There will be answer, right, for my children. So can, in that case, can I write this?
Yeah.
When you would have done DFS, you would have gone here first. You would have wrote
Yeah.
one, and when you came back, you would have added one. When you
Yeah.
went to DFS, you would have done one, two, and when you came back, you would have added one more two. So 1 plus 2 is 3, plus 1 is extra because of this. So that's what we are doing, right? Subtree size of neighbor से क्या आ
Yes.
जाएगा? You will get all the children. ठीक है?
Children.
Yeah. And now if you see, we have calculated all the 5 information required. Depth, parent, subtree size, ease leave, number of child. Okay. Now, what we'll do is we'll just create some utility so that we can run this program and visualize what's happening. Okay. Edges off. We need to create one object, right? We need to create
Yeah.
one object. Okay. And one second, just wait for a second. Yep. So now what we need to call DFS, right, to populate all this information. D dot DFS of, we need to pass information. So which node we will consider as root in general? Any road. अरे हाँ ना बोलोगे?
I mean, like that particular thing we are considering, right? That's it.
No. In DFS, I have to call, right? I need to call my DFS. So what is my root? My root is 0
Root
in general.
zero. Yeah. Yeah.
So I will pass 0. So do you think for node 0 will we have any parent?
No.
No.
ठीक है, simple, -1 रख दो. That's all.
Mm.
And what is my depth?
Zero.
Zero.
हो गया?
Yeah.
No. For integer, node equals to 1, node less than or equals to n, node plus plus. ठीक है? We will print all the information. ठीक है? System dot out dot print node. What information do we require? We require d dot ease leaf sorry, I should go from 0 to less than n, right? Because we are having 0 indexed, not 1 indexed. Okay, 0 1 2. So I'm just traveling on all the nodes. That's it. Nothing fancy. Okay, we should give some more extra space probably. What else? What else more? Ease leaf हो गया, depth हो गया, subtree size.
Subtree size.
और क्या चाहिए?
Parents, number of childs.
I'm just printing. I mean, just to show. Okay, बस
Yeah.
Okay, and we will do a println so that each node comes uniquely. Node is this. Okay, leaf depth subtree size parent okay, that's all. Now we shall run the program and probably can see how it's working. कितने nodes? How many nodes shall we take?
We will take small Pabir.
Okay, shall we take this small node, ये वाला, ये वाला?
Yeah.
This is
हाँ.
good, right? Or do you
Yeah.
want to take this node, ये वाला? We'll take this only. Okay.
Hmm.
So how many nodes are there total? 6 nodes.
6.
So I'm 6. Okay. No, edges 0, 1, 0, 2, 0, 3.
0, 3.
0, 1, 0, 2, 0,
0,
3.
3. 2, 4, 2, 5.
ओके, चलो देखते हैं क्या है. तो स्ट्रक्चर ये है, राइट? 0, 1, 2, 3, 4, 5. लेट्स सी. नोड 0, लीफ फॉल्स. ऑब्वियसली लीफ फॉल्स है. डेप्थ 1 आया. व्हाई इट इज डेप्थ 1? Did we pass current depth? We passed 0 only, right?
Yeah. Even number of childs were different, right?
Number of children 11. ये कैसा हो गया? Number of children कहाँ है? Current node. Current node is 0. Okay. I0, I1. तो 0, 1, 0, 2. Did we write something wrong?
Right, there will be a problem DFS only. There is nothing over there wrong.
Depth parent depth में भी wrong आया, right? So current depth is 0, right? We passed 0. Current node is 0. We started with DFS with 0, -1, 0. Oh, it should be parent भी 0 आया. Hey, man, what man? Everything got manipulated.
Yeah.
Okay, I understood what's the problem. Okay. It should be 0 indexed. I kept it 1 indexed. Okay. Sorry for that, but probably. Let's run it again. Okay. ठीक है. कितने नोड्स हैं? 6 और 5?
6. 0, 1, 0, 2, 0, 3, 2, 4, 2, 5.
2, 4?
2, 5.
So there is something going on. Where is the problem?
You tell we are passing in RHS.
देखो, we'll pass 0, -1, 0, right? तो 0
Yes.
current node है. So we'll go recursion. Depth of 0 equals to current node. Parent node should be -1 as per the code. Okay. Subtree size of current node should be 1. Neighbors में जाएंगे. Neighbors is 0. If neighbor number of I don't think any problem, but did we write it properly? I mean, ये सब ठीक ही है ना? D dot depth सब तो 0 से initialize होगा, right? Initially.
हाँ.
And everything is leaf. What's happening?
We are at HS 2R 0
6 nodes, n, 2. And we can do... Deva, can you identify anything?
No, bro. Like, I guess the problems with this DFS traversal itself only.
Okay, but this is correct. At least for the first node, it should be correct, right? I believe. Because
Yes.
first node के लिए तो current node. Okay.
Yeah.
Bear it with me for 5 minutes. Okay, we will probably will clarify it now itself, because I don't want to take this for the next session. Okay.
Yeah.
Okay, just help me out in case if you are able to find anything, or maybe it would be help. I0, I1 adjacency list.
The adjacency list chat.
Depth of current. in these cases,
Is it 0 to
uh
n minus 1 or
where
yeah, adjacency में equal to n?
this one,
Yeah, you have n. Yeah,
yeah, this won't be a problem. No? We are
that's,
just adding it in this. This is not a
yeah.
problem. Okay. So, what to do in this kind of cases?
System not out that println.
Check.
Okay, we'll do this.
Hmm.
देखो इसको this is debugging in VS. Okay. Okay. So first we have 0,
0 1. Yeah, 0.
0, 1. Next. Oh, देखो I have a little bit of thought on this. 6 correct ही आएगा ना? Edge of 5 0 पे 0 1. It should store correct only, I believe, right?
Yeah.
Not sure what's happening. What do you think, Manan? Where it might go wrong?
Edges of I0 is correct only, yeah. इधर ही wrong जा रहा ना शायद नहीं
1 4. ठीक है? And finally, we have assigned that to 1 1 5.
fine.
U1, okay. So we are done with the edges, correct? And
Yes.
do we have variables रहना चाहिए somewhere? But okay, fine. DFS we are creating the object and an edges. Okay, edges का 6 है. Step into. देखो. Current node is 0. Current depth is 0. Parent node is -1. Okay. That is perfect only, right? Subtree size of node is 1. ये फिर wrong कहाँ जा रहा? Where it is going? Parent node -1 है. तो it's working perfectly, man. Why do we get current node is 4? Easily true. Where did we print it? Node number. Interesting. How is it possible? Ah, 6 भाई साहब ऐसा क्या आ गया भाई? What tree size equals to this? Subtree size is this. Subtree size 1 है 12.
तो for loop में जा रहा क्या वो
Understanding, man. We will take a small example. Okay, let's not take a larger. Just. Hey Sam, you're back.
Yeah, I'm there, bro. Like I think you are not able to hear. in that.
We shall take a small example. Okay, 3 nodes बस है, ठीक है, 01 and 02 I guess. And why we are getting this many?
ये क्या रिजल्ट्स के लिए?
इतने क्यों आ गए? System dot
D dot node.
okay, 3 01
02.
why this many is getting printed? नोड 1 के लिए 1 इस for loop only, for loop के बाहर ही है ये वाला, so it should print only once, right? DFS where we called? Exactly, we called only once. Why it's happening many times? ये क्या प्रोग्राम है? D.dfs DFS util जब बनाएंगे, it will go here, it will construct everything whatever is available with us. Okay, then DFS में this is a for loop, this for loop should go 0 के लिए क्या क्या है, 1 and 2, right? So अगर neighbor parent node है तो continue, don't go. Number of child will increase, right? Currently increase होगा because there is one child and we will
उधर प्रिंट कर,
कौन
कर
सा
सकता क्या?
इधर?
हाँ उधर, हाँ
एक सेकेंड. Probably sorry for the inconvenience, but even I am kind of astonished why it is not working. Okay.
ना, सॉरी क्या इसमें, इसी का मजा है.
This is what, right, Manan? What you were talking about is keep.
हाँ
लेकिन मेरे क्लियर अभी भी समझ में नहीं आ रहा व्हाट्स हैपनिंग. अगर कंटिन्यू मार रहे हैं then it should go to, still confused why it's not working. मतलब मैं अभी तक बहुत बार ट्रीज का कोड लिख चुका हूँ ऑलरेडी. भाई साहब देखो कितना बार आ रहा है, नोड 11 नोड 1.
तो कॉल बहुत बार हो रहा है ना.
ये नोड 11 तो ये है अपना. ओके, लास्ट वाला.
रुक, एक काम कर, रिकॉर्डिंग स्टॉप कर,